Have you ever wondered how computers and humans speak different numerical languages, yet always seem to stay in sync? That's the magic of code conversions. Code conversions let us switch numbers between binary, decimal, octal, and hexadecimal systems. This skill is essential for understanding computers, electronics, and digital systems. By mastering code conversions, you're building the bridge between human-friendly and machine-friendly number systems. It's also a great confidence booster when troubleshooting problems or designing digital solutions. Code conversions are all about translating numbers from one code system to another. The most common codes are binary, which is base 2, decimal, which is base 10, octal, which is base 8, and hexadecimal, which is base 16. For example, binary numbers use only 0 and 1, making them perfect for machines, while hexadecimal uses not only digits but also the letters A to F for representation. So, why do we bother with code conversions? The answer is simple. Computers use binary, but humans find decimal much easier to understand. Whenever we're debugging microcontrollers or writing code, we often have to switch between different bases. Programming languages can also represent numbers in various formats. Code conversions are crucial in real-world applications such as networking, cryptography, Unix permissions, and even web color codes. Now, let's explore how to convert a binary number to a decimal number. Start with the rightmost digit, which is in position 0. Multiply each bit by 2 raised to the power of its position. Then, sum the results. For example, if you have the binary number 11011, calculate 1 times 16, plus 1 times 8, plus 0 times 4, plus 1 times 2, plus 1 times 1. Add them all together and you get 27. To convert from decimal to binary, there are 2 common methods. First, you can subtract powers of 2 in order. For example, to convert 45 to binary, you repeatedly subtract the largest power of 2 possible, ending up with 101101. The other method is repeated division by 2. Take 25, divide by 2 and note the remainder each time. When you finish, writing the remainders in reverse order gives you 11001. Converting binary to octal is straightforward if you group the binary digits in sets of 3, starting from the right. Each group converts to an octal digit. For instance, the binary number 100, 111010 is grouped as 100, 111, and 010. These convert to 4, 7, and 2 in octal, making the result 472. When converting from decimal to octal, use repeated division by 8. For example, to convert 177 to octal, divide by 8. The first division gives a remainder of 1, next gives 2, and the last is 6. Writing the remainders in reverse order results in 261 in octal. To convert a hexadecimal number to decimal, multiply each digit by 16 raised to its positional value, starting from the right. For example, the hexadecimal number 2AF is calculated as 2 times 256, plus 10 times 16, plus 15. That adds up to 687 in decimal. To convert a decimal number to hexadecimal, use repeated division by 16. For instance, divide 378 by 16. You'll get remainders A, 7, and 1, in reverse order. Reading them backwards gives you 17A in hexadecimal. Hexadecimal and binary connect closely. Each hexadecimal digit is exactly 4 binary bits. For example, the hexadecimal B2F can be expanded to binary as B equals 1011, 2 equals 0010, and F equals 1111, so B2F in binary is 101100101111. To convert between octal and hexadecimal numbers, it's easiest to use binary as a bridge. Take the hexadecimal 5A8. First, write it in binary as 010110101000. Then group the binary digits into sets of 3 to get the octal equivalent, 2, 6, 5, and 0, so the answer is 2650 in octal. Remember these key points: binary is the foundational code system. Octal, grouped in 3s, and hexadecimal, grouped in 4s, relate directly to binary, making conversions easier. Practice your conversions regularly to build fluency. And keep handy lookup tables for quick reference during your work. The purpose of code conversions is to bridge human and machine representations of numbers. If you need to quickly get the binary equivalent of a hexadecimal value, remember that each hex digit maps directly to 4 binary bits. Use binary for electronics, hex for memory addresses, octal for Unix permissions, and decimal for everyday math. Online converters are also available to simplify your workflow. In summary, code conversions underpin everything from programming to networking and digital design. Regular practice will improve your speed and accuracy. Mastering binary, octal, decimal, and hexadecimal makes larger digital systems much more approachable and manageable.